Think about all the things you see changing every day. An ice cube melts into a puddle of water. That's a physical change where the substance is still just water, but in a different state. But what about when a log burns in a campfire? It turns into ash and smoke, and you can't get the log back. That's a chemical change, and we call this process a chemical reaction. It's a fundamental way the world changes around us. A chemical reaction is a process where the atoms and molecules in a substance rearrange themselves to form a completely new substance with different properties. It's like taking a Lego car apart and using the same bricks to build a Lego spaceship. You started with the same building blocks, but you ended with a brand new creation. In a chemical reaction, the original substances are used up to create something entirely different. To understand a chemical reaction, we need to know two key terms: reactants and products. The reactants are the substances you begin with, the ingredients for your chemical recipe. The products are the new substances that are created. The arrow in a chemical equation shows the direction of the change, moving from the reactants to the products. A great example you've probably seen is the classic baking soda and vinegar volcano. The baking soda and vinegar are our reactants. When you mix them together, they bubble and fizz like crazy. The bubbles are a new substance, carbon dioxide gas, along with some water and a salt. These new things are the products. The fizzing is a clear sign that a chemical reaction has taken place. We can't see the individual atoms rearranging, so how do we know a chemical reaction has occurred? We look for evidence, observable signs that a new substance has been formed. When a baker bakes a cake, they can tell it's done by the smell, the color, and the texture. Similarly, scientists look for these kinds of clues to confirm a chemical reaction. One of the most common signs is the production of a gas. This often looks like bubbles or fizzing. If you drop an antacid tablet into a glass of water, it immediately starts to bubble. Those bubbles are a new gas being released, which proves a chemical reaction is happening inside the glass. Another sign is a color change. For example, when you leave a shiny copper penny outside for a long time, it slowly starts to turn a dull greenish color. That green coating is a new substance called copper oxide, and it's formed when the copper reacts with oxygen in the air. This change in color is a big clue that a chemical reaction has taken place. Sometimes you can feel a chemical reaction happening. This is when there's a temperature change. Some reactions release heat, which makes them feel hot. These are called exothermic reactions. Other reactions absorb heat, making them feel cold. These are endothermic reactions. An instant hand warmer is a great example of an exothermic reaction. It uses chemicals that react to create heat for your hands. Have you ever mixed two clear liquids and a solid suddenly appeared? That solid is called a precipitate, and its formation is a sure sign of a chemical reaction. It's like magic. You start with two see-through liquids, and a new, cloudy or solid substance is created right before your eyes. This happens because the new molecules are not soluble in the liquid anymore. Chemical reactions can also be very dramatic. A firework exploding in the sky is a powerful chemical reaction that produces both light and sound. The chemicals inside the firework rearrange themselves almost instantly, releasing a huge amount of energy in the form of bright colors and a loud bang. This is another clear sign that a chemical reaction is underway. When a chemical reaction occurs, you might think you've lost some mass, especially if a gas is released. However, a key principle of chemistry is the law of conservation of mass. It states that matter cannot be created or destroyed. The total mass of all your reactants will always be equal to the total mass of all your products. The atoms are simply rearranged. None are created or lost. So, how do we describe a chemical reaction? We can use words to tell the story. For example, you can say, iron reacts with oxygen to produce rust. But in science, we like to be more precise, so we use a shorthand called a chemical equation. It's a compact way to describe exactly what's happening. A chemical equation uses the symbols from the periodic table to represent the elements. For the rusting of iron, the equation is Fe plus O2 equals Fe2O3. This shows the elements and molecules involved. It's a way for scientists all over the world to understand the same reaction without any confusion. Let's break down that equation. The Fe stands for iron, and O2 is oxygen gas. These are our reactants. The arrow shows the reaction's direction. The Fe2O3 is a new substance, and it's called rust or iron oxide. This is our product. So the equation perfectly summarizes the entire process of iron rusting. To describe chemical reactions accurately, we need to gather information and data. In an experiment, we can use a thermometer to measure temperature changes, or a scale to measure the mass of the substances before and after. These observations and measurements provide the hard data that helps us describe the reaction and support our conclusions. Let's pretend we're in the lab. We'll put an Alka-Seltzer tablet in a cup of water. What do we observe? We see the tablet dissolve, and lots of bubbles form. We can also feel that the cup gets a little bit colder. Our observations are that we have a gas production, the bubbles, and an endothermic temperature change. It got colder. Based on our observations, we can now describe the reaction. Our reactants were the solid tablet and the clear liquid water. Our products were the bubbly gas and the clear liquid that now tastes salty. We know it's a new substance because the properties are different. We started with a solid and a liquid, and we ended up with a gas and a salty liquid. When you're asked to describe a chemical reaction, it's best to be as specific as possible. Start by describing the starting materials and their properties. Then explain the changes you observed, such as the bubbling or a color change. Finally, state your conclusion, that a new substance was formed, meaning a chemical reaction occurred. Chemical reactions are not just for a science classroom. They are happening all around you all the time. Your body uses chemical reactions to digest food and turn it into energy. Plants use chemical reactions to perform photosynthesis. When you bake a cake or cook an egg, you are creating new substances through chemical reactions. They are essential to life itself. In summary, a chemical reaction is a process where atoms rearrange to create a new substance. We can't see the atoms, but we can look for clues like gas production, color changes, or temperature changes. By observing and gathering data, we can describe and understand these fundamental processes. Chemical reactions are the driving force behind many of the changes we see in our world.